Hello students, good morning and welcome to our maths class. So we are continuing one important chapter, that is trigonometry, and in the first day I gave all the basics about the angle, triangle and definition of trigonometry, the chapter dealing with the triangles. Trigonometry means the chapter dealing with the triangles, its sides, angles, relation between angles, sides, like that. So and after that we took a right angle triangle and I defined, I named the sides of the right angle triangle. What is opposite side, what is called adjacent side, and what is the hypotenuse, I explained. And after that I explained the Pythagoras theorem in a right angle triangle, that is side square plus side square is equal to hypotenuse square. That Pythagoras theorem also I explained. And after that I defined 6 trigonometric ratios. So the name of the two side, ratio of the two sides in a right angle triangle, we have some names. So the ratio of opposite to hypotenuse, we named it as sine theta. So similarly, I defined cos theta, tan theta, cosecant theta, secant theta and cotangent theta. So based on these 6 trigonometric ratios and Pythagoras theorem, so we started the first exercise and almost all except one we completed the exercise. So that last problem let me complete today, and after that before going to the second exercise, again I will give some new formulas, and after that we go to the second exercise. Students, all of you open your textbooks, that is first exercise, one problem left. I am going to solve that problem. So page number 281. Students, page number 281. Exercise 11.1. So we have 8 problems. In that I completed 8 also. Only 6th problem is left. I left this because it is a different model. All the remaining 7 problems are same model. One ratio will be given and we are asked to find the other ratios. So we use the Pythagoras theorem and we use the definition of strict trigonometric ratios. So that is the process we applied for all the problems, same model. So now the last problem, 6th, it is little different and also difficult. So write down. In triangle ABC, write the 6th problem. In triangle XYZ, angle A and angle X are acute and cos A is equal to cos X. Cos A is equal to cos X. Show that angle A is equal to angle X. Students, write the problem. So I will draw ABC triangle and XYZ triangle. 2 triangles. Now I am going to draw the 2 triangles. See here. A, B, C. X, Y, Z. A, B, C, X, Y, Z. A and X are acute angles. So we are discussing about these angles. In this triangle we are discussing about angle A, and in this triangle we are discussing about angle X. Now, so for this angle, this becomes opposite, this becomes adjacent, this becomes hypotenuse. Same way, this is hypotenuse, this is opposite, this is adjacent. Okay, now see here. This is little confusing. This is a little not the same model. So, cos A is equal to cos X is given. Cos A definition. What is cos definition? See the definitions. What is cos definition? Adjacent by hypotenuse. Cos theta definition. Adjacent by hypotenuse. See here. AB by adjacent by hypotenuse. Cos definition is adjacent by hypotenuse. Cos X, same cos definition is adjacent by hypotenuse. Here what is the adjacent side? XY. Hypotenuse is XZ. XY by XZ. Cos is adjacent by hypotenuse. AB by AC. XY by XZ. Now, simply this is given in the problem. Cos A is equal to cos X is given in the problem. I wrote the definition of cos A and definition of cos X. Definition is adjacent by hypotenuse. Adjacent by hypotenuse. That's all. Now, I am taking AB by AC is equal to XY by XZ is equal to some K. Let K. Let us take each is equal to K. So, AB is equal to K into AC. Write like this. K into AC. XY is equal to K into XZ. See here. AB is equal to K into AC. AB is equal to AC that side. K into AC. Suppose if we want XY. K into XZ. Now, see here. Let us take this. See, the relation is between AB and AC. AB-AC relation is known and XY-XZ relation is also known. So, this relation, say some K. Now, I am finding the relation for, I am finding BC and YZ. Let us find BC and YZ. See here. BC is equal to Pythagoras theorem. According to Pythagoras theorem, see, I am writing one direct step because it is a somewhat lengthy problem. So, I am not writing all the steps. So, previously I used to write the full Pythagoras theorem. So, I will write here and directly one direct step I will write here. So, Pythagoras theorem is small side square. Pythagoras theorem statement. Small side square plus small side square is equal to hypotenuse square. This is the Pythagoras theorem. Side square plus side square is equal to hypotenuse square. So, AB and AC some relation is there. So, I want to find BC. So, then BC square is equal to, this is the Pythagoras theorem. BC square is equal to what? AC square minus AB square. Or if you remove the root, directly we will get BC square is equal to AC square minus AB square. BC means root of square. If you remove square, you will get right side root. Root of what? AC square minus AB square. See, I have written direct step. Directly, if you see, you may get confused. So, just look at this. BC square is equal to AC square minus AB square, or BC is equal to root of it. Now, see. AC square, in place of AB, I will write K into AC. In place of AB, I will write K into AC. AC square common. AC square common, right side outside the root, square root cancel AC. If AC square common means 1 remains minus K square remains. BC is equal to AC into root of 1 minus k square. Same way I will prepare the relation for this xz also, because xy and xz. So xy and xz already relation is there. So I am preparing the relation for yz, Pythagoras theorem. See here. Yz is equal to root of, this side is equal to root of, same formula, same way. So hypotenuse square minus adjacent square. So in this, xz square minus xy is equal to k into xz. Same rule, k into xz square. So xz common, outside the root, square root cancel xz. See here, 1 minus k square. Write down up to here, understand up to here. So I will explain the last 3-4 steps again. See here, cos A is equal to cos x. This is given in the problem. Cos definition is adjacent by hypotenuse, AB by AC. Their cos definition is xy by xz. Let us name it as 1, and each is equal to k. So AB is equal to k into AC, xy is equal to k into xz. So after getting the relation between these two, I want to find BC side. So how to find BC? The side is equal to root of hypotenuse square minus adjacent square. Why I am writing this rule like this? This is the Pythagoras theorem. This is the formula. AC is same, but in place of AB I will write k into AC. AC common, 1 minus k square. Same rule for this. So yz is equal to root of hypotenuse square minus adjacent square. Same. Write down up to here, and after that I will explain. Next step I will write BC by yz. BC by yz. So what is BC? AC into root of 1 minus k square by xz. This yz is C. Up to here you write down. I am dividing this by this. So this is value of this BC, and xz value is this. Root 1 minus k square cancel. AC by xz remains. Write down up to here. This is little different and a little difficult than the remaining problem. So you have to observe the steps and you have to remember the steps. And same problem is given in the example also. You can see that example also. Write down up to here. Neatly, step by step, you understand and draw these two triangles also and write all the steps. And if you are not following, again you can put in the chat box question number, and if you are understanding, okay, understood. Otherwise, not understood also you can write. Write down. Now, last 2-3 steps. Continuation. See here. Don't write. You write afterwards. Again, take the first equation. Taking the first equation again. Already we wrote this, no? So, again that same equation. This is not a new step. So already I named it as 1, same continuation. So take this, don't write. Bring xy to this side, AC to the right side. Xy is in the numerator. If you bring it to the left side, it will be in the denominator. This is in the denominator. If you take it to the right side, it will be in the numerator. Already denominator is xz. See here. AB, xy, take it to the left side. It is in the numerator. It will come to the denominator. This is in the denominator. It will go to the numerator. Next step. See here. Don't write. AB by xy is equal to AC by xz. AC by xz. AC by xz is equal to BC by yz. See here. AC by xz is equal to BC by yz. From second. See, this already we wrote. Simple. Cos A is equal to cos x is given in the problem. From that I used the cos definition adjacent by hypotenuse. I got this. We named it as 1. Simply what I am doing, I am taking xy to the left side, AC to the right side. AC by xz. AC by xz is equal to BC by yz. So if you combine these two, this is equal to BC by yz. From 2. In AC by xz is also equal to BC by yz. Now, if you observe these two triangles, see here, AB by xy is equal to AC by xz is equal to BC by yz. If the ratio of corresponding sides are equal, this is side similarity. You studied in the 9th class, SSS similarity. Side similarity between the two triangles. So if the ratio of the three sides are in two triangles, if ratio of the sides are same, AB by xy is equal to BC by yz is equal to AC by xz. If the ratio of these three sides are equal, then you studied in the 9th class, triangle ABC is similar to triangle XYZ. Triangle ABC is similar to triangle XYZ. This is SSS similarity. So if the ratio of the sides are equal, the two triangles are similar. See, this is a similar symbol. So similar means corresponding angles are equal. If two triangles are similar, then angles also equal. Corresponding angles. Angle A will be equal to what? Angle X. B equal to Y, of course, and C equal to Z, like that. So these two triangles are similar. Why they are similar? The ratio of the sides is same. They are similar. Similar means corresponding angles are equal. That means angle A is equal to what? Angle X. Which is the required proof? That only we required to prove. So this is little difficult, I told. So write neatly and practice it. We have same one example also. If you do it, you will get more practice. Write down. Complete this problem and exercise is over. Students, exercise is over. Triangle ABC is similar to triangle XYZ. If two triangles are similar, angles are equal. Angle A is equal to angle X. This is the concept you studied in the similarity of triangles in the 9th class. Again in 10th geometry, also plane geometry, we may get this again. It may repeat. We may use this. Write down fast. Over? Okay. Now exercise is over. So you practice all the problems and write down this homework for this exercise, and after that we go to the next exercise. Compulsory you have to complete this homework. (279) page, example 1. 280 page number, example 2. Example 3. These 3 examples you have to do. So, and next practice the 6 trigonometric ratio formulas and also Pythagoras theorem. Write down this, then we go to the next exercise. Write down. See, for the next exercise, I am giving some formulas. You have to remember those formulas. But even I will prove that formula also, how the formula came, that also I will prove. So, actually proof may not be required, but if you remember the formula, that is sufficient. But I am giving the proof also. I am going to prove that formula. So, write down the first one. Values of trigonometric ratios. Write down. For 45 degrees. Values of trigonometric ratios for 45 degrees. Student, see here. This is a right angle triangle. And I will take a isosceles right angle triangle. Isosceles means, right angle means 90 degrees. Isosceles means I will take these two sides equal. These two sides as equal. See, I am taking a right angle triangle. Right angle is at B. This symbol is enough. No need of writing 90 degrees. Symbol represents 90 degrees. So, isosceles means two sides are equal. If two sides are equal, these two angles will be also equal. So, two isosceles means two sides are equal and angles opposite to them also equal. Then what will be these angles? Total sum of three angles is 180 degrees. 180, in that 180, this is 90 degrees. So, what will be the remaining? 90. 90 plus 90 is 180, no? If this is 90, remaining is 90. 90 can be taken as 45, 45. This is a triangle I am taking. This is of course 90 degrees because everywhere we are taking the right angle triangle. These two angles we don't know. But I am taking a isosceles, that is two sides are equal. I am taking two sides equal. Isosceles triangle. So in that, if two sides are equal, two angles also equal. If this is 90 means remaining will be only 90. 90 divided into two parts, 45, 45. So if these two sides are equal, suppose if I take this side as A, this side is also A. Suppose if I take this side as A, this side is also A. Why? Angles are equal. I am taking isosceles triangle. I am taking this type of triangle only. So I am taking two sides are equal. So what is this side? We have to find. Write down the introduction. Let ABC be a triangle, ABC be a isosceles triangle. Isosceles means two sides are equal. And angle B is 90 degrees. Which angle we are taking? 90. Angle B is 90 degrees. Let angle A is equal to angle C is equal to 45. This is 45, this is 45 because two sides are equal means two angles are also equal. And let AB side is equal to BC side is equal to A. I am taking AB as A, BC also A. Now, this triangle is taken, it should be very clear. I am taking isosceles triangle, two sides equal I am taking. So, if it is A, this will be also A. If this is 45, this will be also 45. This is hypotenuse that I am finding. See here, if two sides are given, any two sides are given, to find the third side, we use the Pythagoras theorem. See here, according to Pythagoras theorem, hypotenuse square is equal to opposite square plus adjacent square. Pythagoras theorem. Bigger side whole square is equal to smaller side square plus smaller side square, or any order we can write. So, bigger side whole square is equal to smaller side whole square plus smaller side whole square. This is the Pythagoras theorem. AC is equal to root. Remove the square, we will get root. AB is A. See here, BC also A. A square plus A square is 2A square. Root 2 is same. Square root cancel A. See, AC square is equal to AB square plus BC square, Pythagoras theorem formula. That you should be perfect. In any order we should write. Any side, any order. Every problem we are using that Pythagoras theorem. AC square is equal to AB square plus BC square. AC we don't know. So, removing the square, right side will get root. AB is A square. BC is A, that is A square plus A square, 2A square. Root 2 is root 2 only. Square root cancel A. Now, see here, don't write. What is sine 45? See here, very important formula we are writing, sine definition. What is sine definition? What is sine definition? Sine is, this side we got it as root 2, you know. Okay, first you complete this, after that I will write. You complete this. Draw the triangle and up to here you write down. Draw the triangle and up to that you write down. Students, are you understanding? Is the numbers are visible or not? You just tell me, otherwise I will write big. See here, sine definition. What is sine definition? See the sine definition. All 6 trigonometric ratios I defined. What is the sine definition? Say this is opposite, this is adjacent, this is hypotenuse for this angle. Sine definition. What is sine definition? Opposite by hypotenuse. Opposite is BC. BC by AC, opposite by hypotenuse. Sign definition. What is BC? A by what is hypotenuse? Root 2A. A cancel 1 by root 2. So remember sin 45 value. Here onwards, many problems we require this sin 45. So you have to directly write wherever you get sin 45, you have to write the answer 1 by root 2 directly. So we don't derive all this. Wherever we get sin 45, we write 1 by root 2. Next, cos. See the cos definition. Cos definition. Adjacent by hypotenuse. See the cos. See the definitions. Adjacent is AB. Hypotenuse is AC. A by root 2A. Cos 45 also 1 by root 2. Remember this. Cos 45 also 1 by root 2. You have to remember this value. Next, tan 45. Tan definition. See tan definition. Opposite by adjacent. Tan definition. A by A. Cosecant definition. Hypotenuse by opposite. Hypotenuse is AC. Opposite is BC. This is root 2A by A cancel root 2. So wherever you get cosecant 45, you have to write root 2. Similarly, secant 45. Secant definition, just see the secant definition. See the formula, secant definition, hypotenuse by adjacent. AC by AB. AC is root 2A. AB is A. A cancel root 2. So remember this value. Secant 45 is root 2. Similarly, cot 45. Adjacent by opposite. Adjacent A, opposite A. That means adjacent is AB, opposite is BC. A by A1. So remember these values. Sin 45 is 1 by root 2. Cos 45 is 1 by root 2. Tan 45 is 1. Cosecant 45 is root 2. Secant 45 is root 2. Cot 45 is 1. So remember these values. Write down. Write down and you have to practice the values. You have to remember. Students, following or not? Complete it fast. Then I am deriving for copied or not? Did you draw this triangle? Now I am deriving the same trigonometric ratio for 30 degrees and 60 degrees. So for this, I am taking equilateral triangle. Equilateral means each angle is 60 degrees. Equilateral triangle 60, 60, 60. Each angle is 60 degrees. Right now, let ABC be a equilateral triangle. Equilateral triangle. What is the rule for the equilateral triangle? Each angle will be 60. Angle A is equal to angle B is equal to angle C is equal to 60 degrees. Each angle is 60. Suppose if I take this side as A, this will be also A, this will be also A, because equilateral. Equilateral means all three sides are equal. All three sides are equal. So that means let AB is equal to BC is equal to CA is equal to A. AB is A, BC is A, CA is also A, CA or AC. Anyway, you can write. CA or AC both. So ABA means BC also A, CA AC also A, because it is an equilateral triangle. All sides are equal. Let us take like that. Right now. But to define the trigonometric ratios, we require a right angle triangle. This is not a right angle triangle. It is an equilateral triangle. There is no 90 degrees. I am making a right angle triangle. From here, I will draw a perpendicular line. From here, I am drawing a perpendicular line. Perpendicular means it will make 90 degrees. Write down. Draw AD perpendicular to BC. Draw AD perpendicular to BC. I am drawing a perpendicular line. Perpendicular means it will make 90 degrees. So take this triangle. Take any one side, any one triangle. This side I am taking. In an equilateral triangle, the perpendicular will divide this base side into two equal parts. This total A means this will be A by 2. Half. This total is A, no? This will be half of it. A by 2. This is A by 2, this is A. Then BD will become A by 2. This will become A by 2. Why it is A by 2? Because in an equilateral triangle, if you draw a perpendicular line, it will divide the base into two equal parts. If the total part is A, this is A by 2, this is A by 2. Now forget about the right side figure. Consider only this figure. Consider only this triangle. I am using the Pythagoras theorem. Side square plus side square is equal to hypotenuse squares. Pythagoras theorem. In triangle ABD, this triangle only, left side triangle. According to Pythagoras theorem, BD square, this side square, plus AD square, that side square, is equal to hypotenuse square. Pythagoras theorem. BD square plus AD square is equal to AB square. BD, A by 2. AD, we don't know this AD. AB is A. So we have to find AD square is equal to A square is A square. A by 2 whole square is A square by 4. Take it to the right side, minus 4 LCM. 4A square minus A square. 3A square by 4. So AD is equal to root of this. Removing the square, we will get root. Root of what is right side? 3A square by 4. Root 3 is root 3 only. square root cancel, a by root 4 is 2. So this side we got it as root 3 by 2a. Write down. Up to here you write down. ABC is an equilateral triangle. Angle A is equal to angle B is equal to angle C is equal to 60 degrees. Let us take A is equal to AB is equal to BC is equal to CA is equal to A. Draw AD perpendicular to BC. So this will divide the base into two equal parts. This will be A by 2, this will be A by 2. This is A by 2. So this triangle I am taking, it is a right angle triangle. I am using the Pythagoras theorem. Side square plus side square is equal to hypotenuse square. BD square plus AD square is equal to AB square. BD is A by 2. AD we don't know. AB is A. So A square by 4 right side minus A square by 4. 4 LCM. 4A square minus A square is 3A square by 4. Remove the square, we will get root 3 only. Square root cancel A. Root 4 is 2. Right now. See here, sine definition, opposite by hypotenuse. Don't look at the second half, only this triangle you take. Sine definition is opposite by hypotenuse. Opposite by hypotenuse. So what is opposite in this diagram? AD is opposite. Hypotenuse is AB. AD is how much? Root 3 by 2a. By AB is A cancel, root 3 by 2. You remember the sine 60 value. Wherever you get sine 60, the answer is root 3 by 2. Cos also, write down. Adjacent is BD by AB. BD is A by 2 by A cancel 1 by 2. Tan is opposite by adjacent. Root 3 by 2 by A by 2. Root 3 A by 2 by A by 2. A cancel 2 cancel root 3. Same way you prepare for these three also. So you remember these values. Tomorrow I will explain for 30 degrees. So because time is over. So